Thank you for the opportunity to present my research. I am grateful for the guidance by Dr. Leon and the supporting committee members. My name is Evan Gertis. In this presentation, we will discuss the design and implementation of the automatic word match generator. Practice cannot fail. For the things we have to learn before we can do them, we learn by doing them. Men become builders by building, and lyre players by playing the lyre. Aristotle. An automatic word match generator is a software tool that can be used to generate word matching interactives automatically. The purpose of a word matching interactive is to provide students with a mechanism to learn new vocabulary and improve their reading comprehension skills. This thesis will present the design and implementation of an automatic word match generator, as well as the research and algorithms used in the program. In this presentation, we will review the problem and motivation behind what we did, the literature supporting our research, the methodology that we followed. Finally, we will show the results of our efforts. So, students tend to face difficulties when they are required to learn new terminology. For example, understanding how to differentiate between the terms hardware and software can be challenging for beginner computer science students. Word matching games have been used by instructors to teach vocabulary to students. Previous researchers, Nickman and Hussein, utilized a technique called Make-A-Match, which has been shown to be successful for teaching vocabulary and developing reading comprehension skills. Al-Masari and Najjar applied this concept, except they used pictures and words. Fast Forward Products developed a set of software-based word matching games that were shown to help improve reading comprehension and vocabulary skills by the Brigance Comprehensive Inventory of Basic Skills. Google Trends showed that Udemy usage increased during the pandemic around March of 2020. This indicates that there was an uptick in the usage of online learning. The trend could indicate that online learning is now accepted. Online learning platforms like Revel use interactives which have been shown to help students improve their average Quizletter grades. We'll go through a review of the literature. Figure 1 shows an example of Make-A-Match. Former and Quran originally created the concept of Make-A-Match in 1994. In the implementation by Nickman and Hussein, they split students into two groups, Group A and Group B. Group A got a question while Group B received an answer. Then Al-Masari and Najjar used a variation of this technique, except theirs used pictures and words. In both cases, the average post-test score in the experimental group was higher than the average post-test score in the controlled group. Nickman and Hussein's research revealed post-test scores of 80.40 for their experimental group and 77.20 for the control group. The measured p-value of the post-test was less than the significance value of 0.05. The results of a two-tailed t-test with a degree of freedom of 29 was 19.28, which was greater than the t-value of 2.045. Fast Forward Products took a previously successful concept, computer software that focuses on developing learning and cognitive skills, and improved upon it. They provided computer-based products that combined an optimal learning environment with a focus on early reading and cognitive skills. Figure 2 demonstrates that students gained 3 and 1.5 years in reading grade level. Their average letter-word identification improved by 14 months. Their average gain on the passage comprehension subtest of the Woodcock-Johnson 3 tests of achievement was 2 years. If we pay attention to this specifically, this red line on the graph, we can see that over the period of time as students practice these matching games, their ability to complete the matches increases and reaches a steady state. So we can see that as the days of participation increase, the average percent complete also increases and reaches a stable state. This figure shows that there was a spike in Udemy usage. It is possible that this peak can be attributed to the forced isolation brought on by COVID-19. The consequences of the pandemic were unstoppable and uncontrollable for higher education industries, much like the rest of the world. Most higher education systems are now operating through e-learning platforms. It is possible that the stabilization of this curve implies that the world has adopted the usage of online learning platforms like Udemy, Udacademy, Swayam, and edX. Our research will help students who are either studying or working remotely. Now we'll discuss the success of interactives used in Revel. Revel is a program used both at home and in class. It is an online learning platform. It provides students with a process for practicing what they've learned. Revel interactives provide an integrated live example, which helps students improve the retention of key programming concepts through the application of running and modifying live code. Figure 4 shows a strong positive correlation exists between average Revel grades and average quiz grades, where the correlation coefficient R is equal to 0.50, thus indicating a positive relationship and a p-value of 0.01. Figure 5 shows that the higher the Revel grade, the higher the average exam grade, at least a 17% increase, and a lab grade of a 32% increase, and a final course grade of a 12% increase. Figure 6 shows a strong positive correlation exists between average Revel grades and final course grades, where R is equal to 0.67 and P is less than 0.01. The correlation coefficient indicates that there is a positive relationship between the final course grade and the average Revel grade. Figure 7 shows that the higher the average Revel grade, the higher the average Quizletter grade, at least a 22% increase. And Figure 8 shows that the average exam grade increased from 59% to 70% from spring of 2015 to fall of 2015 for students who used Revel. In Figure 9, we see the results of a two-tailed t-test. So the t-test measures the means of the two groups and whether there are statistically difference. Figure 9 shows that the average exam grades for spring of 2015 and fall of 2015 experienced a change. The results of the t-test show that the students in fall of 2015 scored 70% and the students of spring of 2015 scored 59%. The sample size used for this data was around 118. This indicates that the increase was statistically significant. Now we'll discuss the requirement specification. Instructors shall be able to automatically create interactive word matching games. Students shall be able to access the games online. From a developer perspective, the following specifications are required. Enable the storage and retrieval of word matching interactives, capture the input data necessary to create word matching interactives, provide a web interface for displaying word matching interactives, develop a drag and drop algorithm that facilitates an interactive learning experience using the derived data from the output. Figure 10 shows the before and after picture of the automatic word match generator. The implementation of the custom three-tiered application was non-trivial. As we can see in the top left, the original word matching interactive that we used was a simple static HTML, JavaScript, CSS page. The after picture shows the custom three-tiered application, which consists of a controller, service, and view. So when an instructor visits the instructor GUI, the graphical user interface, they can create a word matching interactive, which is sent to the server. In that request, a handler picks up the request and routes that to the controller. The controller then processes this request, which calls a service method, which processes the content in the request to be saved on the file system of the server. Then, once that process is complete, a response is returned back to the client. The client then shows a view button to the instructor. The instructor can click this view button and then pass it to a student and allow the student to access the word matching interactive completely remote. So, first we selected languages for developing the program. Java was selected based both on mine and Dr. Liang's familiarity with Java. Then we identified the input and output. Then we implemented the functionality based on the requirement specification. We will discuss what a word matching interactive is in subsequent slides. We'll go through the algorithm design. The crux of the algorithm is the conditional comparison of the source index being equal to the target index. In step 1, we obtain the index of the dragged key term as a source index. In step 2, we obtain the index of the row where the key term was dropped as a target index. If the source index is not equal to the target index, we return the key term back to the key term pool. Then, in step 4, we disable the key term object to be undraggable. In step 5, we set a new color for the matched row object. In step 6, we test if all key terms are matched. If so, we display a congratulations dialog. In step 7, we increase the success count by 1. In this process, we'll discuss the testing of the automatic word match generator. So figure 11 shows the user interface that would be presented to an instructor. Figure 12 shows the user interface after it has been pre-populated with key terms and descriptions. Figure 13 shows the instructor interface after the static HTML has been generated. The window at the bottom of the page shows the code used to create word matching interactives. Figure 14 shows the instructor user interface after the word matching interactive has been posted to the server. Figure 15 shows a word matching interactive that features the key terms from the Introduction to Java Programming. The basis of our research stemmed from generative programming and code generation. Generative programming is the application of reusing code for a new function or software. Code generation is a mechanism used to produce an executable form of a program. The automatic word match generator is an example of an application that uses automatic programming. It provides an end-user interface. Instructors can access this interface by visiting the word match generator route, and students can access the word matching interactives by visiting the URL for their word matching interactive exercise. Instructors do not have to write the code to create this word matching interactive. All they have to do is fill in the key terms and descriptions and post it, and everything else is created automatically. Now we'll discuss the automatic programming aspect of the project. A generic input can be applied to this process, then a web page output can be generated. In the case of the automatic word match generator, input is entered from the text fields and stored in arrays. Validation checks if the key terms or their descriptions are empty. In process data, data is shuffled randomly and the key terms are mapped with descriptions. Then we create a web page, which is used to create HTML, CSS, and JavaScript to produce a word matching interactive. Then we post a web page automatically, which creates a web page on a web server so that the page can be viewed on the internet. So, in conclusion, word matching interactives provide students with the intent to improve their vocabulary and reading comprehension skills as shown in the learning curve from Fast Forward Products in Figure 4. Interactives have been shown to improve student performance on quizzes and tests as shown by the test results from Revel from Figures 5 through 9. In this case, we can look at a live demonstration of the word match generator. So, this is typically where we would host the word match generator. We can go ahead and run a live example here. I will go ahead and open Visual Studio Code. We can see that this is the code that runs the word match generator. Go ahead and close that. We'll clear the interface, and then we will change the Java version to Java 1.8, which is the runtime version for the Java virtual machine that we're using. Then we'll type the command maven spring boot run, which is featured in the user manual for the automatic word match generator. So we'll start the application. Now we'll go to the local host. word match generator. We'll type in the title, Spanish quiz. And we'll type caballo for the key term, horse, burro, donkey. Then we'll click Generate HTML. This creates the HTML, the static HTML that we need for the word match generator. You can go ahead and adjust the screen here. We'll go ahead and click Save. Now View. We have both of these terms here. We can try and drag caballo to horse. We see that it gets returned back to the key term pool. And drag correct term to the correct description. Now we'll turn on the speech synthesis for students who have difficulty reading or interpreting the screen. The speech synthesis provides them with the ability to hear the words in their descriptions.
Cabello. Horse.
We can check the answer. This shows the answer in case the student struggles with the test. We'll go ahead and reset. This brings us back to the original page. So, any questions? A quick search of similar projects show examples of sites that are overly complicated and difficult to use. For example, the Teacher's Corner provides a matchup worksheet maker. This worksheet maker is very complicated, doesn't really seem totally intuitive, and there's a lot of things for students to get distracted in. We can look at the way that this is created. The site is ineffective because it is covered in ads. It is frustrating to use. Just trying to type in a key term and definition opens a tab. It's not made for instructors, it's a gimmick. You can see that we go through this, we create the quiz, and then you have this pop out that has a button over here that you have to press, and someone has to kind of see that, and if they can't see that, then they're probably just going to give up using it. Whereas with Word Match Generator, we are using it in Revel, which is a online education tool that students have been using for quite some time. And as we saw from figures 5 through 9, it has been proven to be an effective teaching tool. It's a part of the Revel curriculum. They're using it very frequently. It's very simple, very intuitive. So, you can also take a look at an example of this being used live. Here we have a group of students. So, changing connection.
The bottom one?
This one?
Mm-hmm.
I think it's the...
This one?
No. I just...
Site.
The equal sign. The equal signs goes to the bottom.
Equals. Assignment operator assigns a value to a variable.
Okay. So we can see that this is a successful teaching tool. It gets students to think about what they're doing, tests their knowledge, and helps them improve. Thank you for paying attention to this presentation.